So today is about bases and exponents, and I think kind of the best thing is just to kind of see a bunch of examples. So I'm going to talk about some vocabulary with our bases and exponents. And first of all, you need to know that if you see something like 3 to the 4th power, the thing that's on the bottom is called the base, and the thing that's on the top is called the exponent. So base, bottom, exponent, top. Yeah, that's just where they're located. Just for information in case you didn't know. And then the second thing that we're going to talk about is what happens when you see something and it talks about writing it in expanded form. So for example, if you see that 3 to the 4th power, expanded form means that you're writing it as 3 times 3 times 3 times 3. Because that's what 3 to the 4th means. And so the expanded form is what happens when you write it all out. So a power function is when you see something that looks like this, x to the 7th. It's where the base is x and the power is a number. So whenever they talk about a power function, that's what they're talking about. If you remember, we talked about exponentials earlier. That's where the power was the x and the number was the base. But in a power function, the base is x and the power is a number. Bless you. There are a lot of rules that are associated with exponents. And they have all those rules listed here in this box. And I thought it might be good for us to see examples of each one. So what I'm going to do is right next to each property, I'm going to show you an example from each one. So let's look at the first one. The first one is called the product property, and what that means is when you multiply. And what that's saying is if I take something like x squared times x to the 7th, you get x to the 9th. Or in other words, you keep the base and you add the exponents. That's called the product property of exponents. The second one is called the quotient. So if I do something similar, and I take something like x to the 7th, and I divide it by x squared, my answer is x to the 5th power. Or in other words, I'm subtracting the exponents to get my answer. That's called the quotient power. Or the quotient property, either one.
Wait, Mr.
So on this next one, I'm going to show you two examples. It's the negative exponent property. So the first example I would like to show you is what if you have something like x to the negative 4 power. And what that's saying is it's the same as 1 over x to the 4th. So what a negative exponent does is it's telling you to change the position on the fraction bar. Notice how the x to the negative 4 is not even part of a fraction that we see, but I could always put it over 1. And if I move the x base down into the bottom of the fraction, notice how the exponent changes sign. Not the x doesn't change sign, just the 4. Another way you could think about it if you wanted to, is you could also look at if you had a fraction. For example, if I said, what is x over 7 to the negative 2 power? That's really like saying, flip the fraction and change the power sign. So in either case, the big idea is change the position on a fraction bar. Flip it. Zero exponents. Zero exponent is telling us that anything to the 0 power is 1. So I could take something like 7 to the 0 power, and that's 1. I could take x to the 0 power, that's 1. Anything to the 0 power is 1. Power of a power property is when you see something like 3 to the 5th power, and then that gets raised to another power like 2. And what that means is I really have 3 to the 10th power. So whenever you see two powers right next to each other, one inside of parentheses generally speaking, and one outside, you multiply the exponents. So a power to a power, you multiply them. The next one says, what if you have two things being multiplied inside and it's being raised to a power? So for example, what if I did 2x, and I want to raise that to the 6th power. And what happens is each thing gets that power. So really this is like saying 2 to the 6th power times x to the 6th power. Both things get the power. So that's the power of a product. Product means two things are being multiplied, and you're raising it to a power, so actually both things inside got the power. What were the exponents on both the 2 and the x? What were the powers, the exponents, for the 2 and the x? Inside. 1. They don't write them there, but it's a 1. So just a reminder. Power of a quotient works just like the power of a product. So if I'm looking at that one, power of a quotient, what that's talking about is, what if I had two things being divided? Like 3 divided by x to the 7th power. And that means I really have 3 to the 7th divided by x to the 7. So again, each thing is getting the power. Okay, and the power property of equality, this is usually used to solve equations. So this one's talking about if I look at something like 3 to the x power equals 3 to the 2nd power. That's a horrible color, I'm sorry. Let me try something different. If 3 to the x power equals 3 squared, that means that I know that the x has to be equal to 2. Because if the bases are the same, then the powers have to be the same. So that's what the power property of equality is saying. And that kind of goes with, I guess, the last one as well. So I would actually put those two together. They kind of work in conjunction with each other. So this one's going backwards. So the last one is saying the same thing, but go the other way. If I know that the two things are the same, then those two are the same. And the other one's saying if I know that the bases are the same, then the powers are the same. Same kind of deal. They both work with the same stuff I just wrote down there in that brownish color stuff. Questions? Okay, example number 1. One of the things that's kind of important is to know how to solve equations with exponents. So the big idea oftentimes is to get the bases of the